we'll get started. So this next section, about the next 20 minutes, we're going to go in and have a discussion panel with the leadership within PEO C3T. We have some questions that Dr. Hassan's going to moderate with the panel, as well as after that, we'll have some prime manufacturers join to discuss business models, and then we'll open it up for Q&A as well from the audience for the whole group. So without, I think we're good there. Dr. Hassan, do you want to kick it off and get started?
Sure. Thank you, Nima. Good morning, everybody, and welcome to PEO C3T program fireside session. We have, as Nima stating, we have three distinguished panelists in this section. Let me introduce them formally. We have Colonel Garth Winderly, Project Manager, Tactical Radio PEO C3T, Lieutenant Colonel Sharita Windleton, Product Manager, Waveform PEO C3T, and Mr. Dan Dubach, Deputy Assistant Director. He has a long organization. It's called Network and Spectrum Dominance Research and Technology Integration Directorate, DevCom CFA Sir. Did I do it right, Dan?
Yeah, thanks, Saeed. Yeah, and in some restructure. So yeah, formerly ran the RF comms division in the S&T group.
Okay, I think there's probably a store off post that sells those desk things with the titles on it. They're just trying to keep them in business. They keep changing these names.
Yes,
Roger that. And I'm Dr. Saeed Hassan, Chief Engineer for PDM Waveform, and I'm honored here to serve as a moderator for the session. So the first question goes to Colonel Winterly, and the question is, with the advent of the X-Tech Waveform Challenge and the approach to separate the hardware and the software, what advantage you think, sir, is the Army hoping to realize from this approach?
So just to first give everybody a background on kind of where we are on our hardware software platforms when it comes to tactical comms. And I'm specifically in charge of the RF component of the upcoming CMOS migration, which is scheduled to start probably at least at TRL 7 plus, around the FY24-25 timeframe. So I'm going to be very RF specific. So if you have questions about, and typically I also have the tactical ground waveforms, and I have MUOS beyond line of sight, but I don't do, other than MUOS narrowband SATCOM, I won't talk on behalf of like JVCP or any other wideband SATCOM systems that are out there either. So I am a little bit more focused than you might wish. So, but we do have guys like Dan and Syed that understand all that stuff much better than me if you have further questions. But so where are we on the tactical comms? So if you really look at our terrestrial and narrowband SATCOM platforms, namely our two Manpack radios and our two leader radios, both 2 channels, they are software defined, right? And they are capable of accepting modernized waveforms to include the future, CryptoMod compliant version of SINGARS, which is a government waveform. We're continuing to modernize the WREN, or the Warrior Robust Enhanced Networking version of the commercial TSM waveform. And then we've got some legacy SATCOM waveforms, and then of course MUOS on the Manpack radios. But the problem is that because we adopted a non-developmental approach, and we didn't really set an open architecture starting out, and because we started off with pretty much whatever vendor hardware showed up, the hardware platform, as long as it could run the waveforms, it was acceptable. When we got down the road and we tried to put new waveforms that weren't anticipated as part of the original contract award or part of the original strategy, we realized very quickly that the difference in the reference hardware that were built into these radios, and the difference on the platform like when we use TSM as an example, and the software we're trying to put on those platforms was dramatically different between the vendor that sold us the waveform and the OEMs that sell me my radios, and then I had to get that waveform onto those radios. And so it turned into a 24-month and quite expensive, I'm not going to throw out the real number, but it was excessive, a very large amount of money to port that waveform over to these platforms. And so the first kind of approach of the X-Tech Waveform Challenge was to find out, hey, how do we change that dynamic? So how do we come up with either hardware platforms or a new way of doing software waveform porting that cuts that time down and reduces the cost? It makes us more flexible as we move forward, as we identify new threats, or we try to get more, and General Collins mentioned, low probability of intercept, low probability of detect, low probability of geolocation, and anti-jam, is we try to get a more EW resilient network. We're going to need new waveforms. Like SINGARS is never going to really do it all to the point where we need to get it. It's going to get better, but it's not designed inherently to meet all of those conditions. Nor is there one waveform to rule them all when it comes to those conditions. We're going to have to be able to specialize based on the missions. And we can't do that if it takes me 2 years and tens of millions of dollars to get a waveform ported to all 4 of my platforms. Because we will have a mixed formation out there with different brigades using different combination of manpack and leader radios. At no time, and really our competitive approach would not allow us to just sole source and consolidate our network to one platform to rule them all. Hence, sort of one of the main reasons why RF is a great candidate to move towards CMOS as part of a chassis, so that we port to a card. We try to make that card as flexible as possible, but then I can configure mission loadouts as needed when I deploy to a theater. And I know I got Robert Laura's listening in, but spectrum, especially when you go to places like Europe and the Pacific, is a lot harder than it is over here, and it's different. I'll use an example. So we're doing the 2nd Cav Regiment Striker characterization for the ITN modernization effort, and we deployed over there, and we have entire countries like Poland, for example, that basically blacklisted the entire L band. And some of our main mid-tier backhaul radio systems, line of sight, are L band, right? And so now you're like, well, what do I do now? Like I bought L band radios, I can't use them in Poland. Well, guess who goes to Poland a lot? People in Yukon, because that's a main training area. So those are the kind of things we're trying to pull out of this. One, is there an easier way to sort of port waveforms and be more flexible? 2, is there a way to go to more of a card-based solution in order to facilitate, flexible loadout? And 3 really is the spectrum challenge, and that's really kind of a part and parcel of basically all, both of the previous 2 things I mentioned. But we need to be more flexible and mission focused. And right now we're sort of locked into an architecture. And one, I want to optimize that architecture if I can first, because that's probably the interim bridging solution. Probably a little more achievable and affordable than totally changing over to CMOS. But CMOS is really the end objective and kind of where we need to go. So I hope that sort of answers that question.
Sir, you stated very well. Actually, those are the 3 key areas that we focus to address at the X-Tech Waveform Challenge. I want to go to the second question, and I would request Colonel Winterly to answer that part. And the question is there any functional and accountability risk if a single vendor does not own both the hardware and the software? Back to you.
Yeah. So the easy way to answer that is just to say yes, there's risk, right? But I don't think that would be very interesting. I could probably elaborate a little bit better on that one. So, when we ported the new waveform TSM over to the vendor platforms, and I really had 3 different vendors, but 4 different hardware platforms. We sort of did it through a C5 ISR contracting approach, where you basically ended up establishing like a prime and sub relationship in order to achieve that porting, right? So in some cases, we're going to have to look at, one, how do I, like, let's say I get approached with a new waveform. Like I just went out to Human Proving Ground, and we saw a very promising waveform for low probability detect. It wasn't perfect, but it was very promising. And it's one of the ones that's going into PC21. But it's being sold by a vendor, and they have the intellectual property. It runs on some of their radios, maybe all of them, but not on other vendor radios. And so when it comes to the performance of that waveform, again, I'm going to have a mixed architecture. So I'm going to, if I want to buy that waveform, I've now got to figure out, well, what's the business model in order to get that over onto my other platforms? Or in some cases, am I just going to buy just a very niche mission capability, like a certain number of radios, and I basically do a modular approach, and then if I'm sending someone into an area where I need that capability, do I then only issue out that radio? So there's this separation of what I want out of the waveform, and then really that pairing of the hardware. So we'd like, and this is kind of, this conference is an ability really to start the conversation between potential small businesses that are coming up with innovative ideas and primes that like develop waveforms and sell radio hardware, and hopefully start up the conversation on what is the best business model to approach so that I can, one, partner up with sellers of waveforms and sellers of hardware. How can I get people that may actually be in business competition with each other to work together? How do I protect IP? And how do I do that from end to end? From some of the technical risk, though, if you look at it from a CMOS perspective, so we're going to have a product manager that's in charge of the chassis, right? However many ports we have in that chassis, it's probably going to be out of Mobile Mission Command, out of JBCP, and so they're probably going to start off with a certain core functionality, but we are going to have multiple PMs that are responsible for different capabilities. For instance, I mentioned I'm in charge of the RF part. So the risk is we've got to build enough integration events and bench testing to make sure that as I partner with vendors, either from a hardware or a software perspective, and we start fielding or we start buying cards for test and integration, that I've got the right kind of confirmation or bench testing in place so that when I show up to an integration event on the chassis, that it actually works. And some of that's going to be, how do I reduce risk as a PM? I'm looking for what are my contract structures? What are the partnership, like, am I going to be the lead system integrator for my components? I hope not, because I don't have a lot of that subject matter expertise in order to do that. So I'm likely going to find a contract relationship to put a vendor in as much as possible in charge of total system performance. So I'm going to ask that vendor to probably find some primes or form partnerships so that I have a single point of contact, so that when I buy an integrated product, it is complete. And then I have a single belly button to sort of push if things aren't working right. So those are really kind of the main challenges. And from an accountability perspective, again, I'm going to look for the ways to, even if it costs me more money, to reduce my technical risk and improve the likelihood that we're going to field a successful product. Now you're going to have, this is going to get complicated as we have multiple PMs come to the table with multiple cards. But I still think it's achievable as long as the PEOs, and I say that in plural, really form strong relationships and processes and partnerships with C5 ISR, other whoever else owns a commodity or a capability in this structure, so that when we prepare for integration events, we walk into it with our eyes open. We make sure we're prepared for it. First of all, we make sure we do it right. We do the right integration events so that we come to the table with a finished product. From an RF perspective in particular, I'm going to have to manage, it's not just a card and it's not just a waveform. I think one of the vendor pitches earlier, talked of ComSec. I'm going to have to make sure I have a radio card that works in a chassis. That radio card's going to have to output what I need it to do. It's going to have to go through ComSec. There's going to be elements of ComSec and Transec. And then I've also got to get it out to an external radio head with some sort of a power amp to make it work. And all of that, those are all potentially different vendors from end to end. And so that's going to be, I think, a great conversation topic with all of you in this conference, with a lot of different industry partners on what would be a way to do that in the most effective and efficient way. So I think I've talked long enough on that one.
No, thank you, sir. These are really all good insight. Before I continue to the next question, Devin, is it okay if we extend this by 5 more minutes to cover 2 more questions? Question to Devin?
Yeah, yes.
Okay.
We just want to make sure we leave time to get the primes up and have a larger discussion with the whole group around it. So go for it.
All right, thank you. So the next question that I'm going to ask Mr. Dan Duvak, I think that question would be kind of appropriate for the C5ISR community. So the question is an open architecture-based solution is safe? What is your take on that?
Yeah, hey, Saeed, and hey, team. Yeah, so from a C5ISR Center perspective, we're the S&T side of the house, so I'll talk to that kind of in a moment. But to answer the question on safety and security aspects, that's certainly something that we're thinking about, right? And as I kind of think through that question, I'd say there's probably 3 areas in particular, maybe 4 areas that we really need to focus on. One is what Colonel Winterly just kind of mentioned, right, from a ComSec and TransSec perspective, and how do we integrate that appropriately if we've got, one vendor on the software waveform side, another vendor on the hardware side. How does that ComSec TransSec work? Is that common across multiple waveform solutions? Is that individual back to each vendor? So there's certainly some questions that need to be answered from the kind of ComSec TransSec aspect of this. Although I think that's probably the easier one once we come up with the right process and way of doing business with that. I don't think there's any huge technical challenges there. The other 3 aspects, though, that I think from a safety and security perspective that are important to probably really think about. First is the underlying architecture on the hardware SDR, on the hardware side of the radio. And I think having a well-defined hardware architecture that takes security into account, things like if your waveform running on that hardware was compromised in some way, or did have a cyber attack onto the software, is there a way we can build in mechanisms on the hardware from an architectural, SDR architectural perspective, so that vulnerability would be limited and doesn't propagate into other radios within the CMOS chassis, or can't infiltrate other VMs running on a server card in that CMOS box. So I think there's some hardware architecture pieces that we can certainly consider. And I think a lot of the vendors that spoke earlier today are already thinking about some of that on the hardware SDR side. The second piece is on the software waveform itself. And I think that's not much different than how radios really are done today. So when a radio comes in and it's got its software running, that goes through a pretty rigorous process to make sure it's not opening any ports, to really check it for vulnerabilities, almost like a similar process that we run through on our laptop computers that we use in our office, right? To make sure that the software pieces have the right, cybersecurity aspects. So I think that's going to be pretty similar to how it's done today on the waveform side. And then the third piece we need to think about is if we're actually changing the firmware on the hardware. So if the software waveform needs to actually change firmware on the hardware radio cards, that's just another piece that we really need to be cognizant of and make sure that we have the proper security checks and cyber vulnerability analysis performed. So those are kind of the pieces there. I would mention in maybe 30 seconds, Saeed, from an S&T perspective, this is a really awesome opportunity. Colonel Winterly talked about that radio that they were testing out in the desert and had great, if it had good LPI, LPD performance, but how the heck does he go buy that, right? What's his whole business plan? Well, what I imagine from an S&T perspective here is that myself and in our labs or working with vendors, we can actually develop those waveform solutions on this common hardware and do those proof of concepts. And it gives us a way to look at really innovative new things. And if we fail, that's okay, because we failed pretty cheaply. All we did was develop some waveform code and maybe it didn't work. And then if we're successful, what it actually leads to is a really innovative solution that actually can transition. And Colonel Winterly has had me in his office numerous times about how the heck do I transition some piece of radio hardware I develop in S&T if he wasn't planning on buying that, right? And then, what does he do? Does he all of a sudden switch and go buy something different? Is it interoperable with what he's already buying? All those questions. Well, I think this solves a lot of that if we can develop an S&T, do the proof of concept this way, and really would aid in transition for those things that are successful. So just wanted to put that out there, and hopefully that was some good answer there on the security question side.
No, these are all good points, and thank you for sharing your thoughts. Truly appreciate that. The next question, I would like to request Lieutenant Colonel Windleton to briefly address that. And the question is, how is the Waveform initiative that we are taking is breaking a barrier of entry for small business? Lieutenant Colonel Windleton.
Thank you, Dr. Hassan, and good morning, everyone. So it is actually a great opportunity to break barriers that small businesses often feel that they don't have the resources to invest in, which ultimately results in missed opportunities for them. The X-Tech Waveform Challenge established a platform for these small businesses to present and ultimately mature their state-of-the-art technologies, and that ultimately helped reduce their investment capital, right? So Colonel Winchley mentioned earlier about partnering with the prime vendors. So this actually provided them opportunities to collaborate and partner with those prime vendors. And the advantages for them partnering with the prime vendors, of course, working with the government. A lot of small businesses do not have that opportunity to partner with the government. So it gives them the opportunity to learn from those prime vendors on key certifications like working with the NSA, the risk management framework, and then of course, ultimately what Colonel Winchley mentioned earlier about Spectrum. So I know we're short for time, so but those are some of the key advantages and barriers that can be broken through the program.
Thank you, ma'am. Truly appreciate your input. Any parting comments from the three panelists, like 30 seconds kind of thing like that? We have like a minute left, so I want to open the forum for three distinguished panelists to say the last comments if they would like, but time has to be
I think just in the interest of time, let's open it up to questions.
Okay.
Hi, this is Ashwin Amana at Andro. I had a question, more of a kind of an acquisition question. You have this, you mentioned a new waveform and a new radio of interest. When you procure this, have you considered maybe buying waveform A and vendor A's radio together, but then also having the specification provided to vendor B and C radio, and then success is defined by interoperability between all three? Over.
So we have looked at one, doing a better job. I mentioned we start off with basically just no holds barred NDI approach, where you just showed up with the hardware you had, and we didn't really pay attention. Because jitters, back in the old jitters days, we tried to mandate every part of the radio hardware, right? And then everyone knows that was an abject failure. We're the last vestiges of the jitters program, and we just got our full rate production ASARC on the 22nd of July. So we're finally moving forward off that history. So we moved way away from that. So we went all the way over on the other side of the pendulum, where we didn't mandate anything. So I completely agree with the concept, and I know you just asked if we thought about it, but I think it's a great recommendation buried in there that we should mandate some sort of interface. And we should try to get as common as possible across our known hardware vendors, so that we mandate one that's achievable and doesn't lock in any particular vendor as sort of over the other vendors as far as an advantage. So that is something we have looked into. We're not there yet, but it is, I think, part of CMOS. We'll be doing that. And then if we continue to buy box radios, instead of a CMOS version, we will probably implement that same concept on any future radios we buy.
Thank you, sir. Devin, before we conclude, I saw a kind of question on the chat. Shall we answer that now, or how you want to handle that?
Let's bring the prime vendors up and move on, and then we can answer that in the Q&A once we have the full group. Does that sound like a plan?
Okay.
Dr.
But,
Hassan.
but before we complete this, then I would like to thank all the panelists, Colonel Winterly, Lieutenant Colonel Windleton, and Dan Dubak for your thoughtful remarks. Back to Devon. Appreciate your remarks.
Awesome.
Thank you.
In addition, we want to keep the discussion kind of going with those points and bring up Mr. Alan Tribble from Principal Program Manager with Collins, Mr. Wes Buss, Senior Staff Software Engineer with Lockheed Martin, and then Mr. Saeed Akbar, Senior Technical Director with General Atomics. And so from that perspective, we want to discuss as well how this how the shift in PEO C3T's business model is going to change kind of the business structure for each of your companies moving forward with the platforms that you have. So I think just to open the floor, do any of you kind of, from what you've heard today, are there any general comments or thoughts that you have from what we've covered so far? I'll start there.
So I'll start and address that. One of the things I came to mind as the Colonel was talking is ownership of architecture versus ownership of performance. So if the government wants a model where they can solicit products from industry and then bring them to an LSI, how can the LSI accept the risk that's associated with performance when they don't own the architecture necessarily? So when I look at this type of model as a whole, that's one of the areas where I have a little bit of concern, is ownership of performance versus ownership of the architecture, and how do you resolve the risks that would be associated with building something where you don't actually own that architecture.
Are there any thoughts, Colonel Winterly, Lieutenant Colonel Wendleton, on your side, Dr. Hassan, are there any thoughts on that?
So I think from my perspective, it would be more of, one, can we find an open systems architecture that we can basically make the foundation of that relationship, right? And then you're basically managing the implementation of different vendor solutions onto that open architecture to make sure they're compliant. So it's more of a plug and play process than, hey, you're going to use this exact hardware architecture, you're not going to deviate from it. We just want to make sure that it interoperates and it operates together as a system, similar to what we're doing with the integrated tactical network. We have an integration facility where we take different commercial solutions and we make sure they interoperate end to end, from the dismounted soldier all the way up through SATCOM, back to the mission command NOC, et cetera. But we're following that interoperability and the data transport end to end. But at no point in time, it's pretty much plug and play. Like if I pull this one vendor radio solution out, put another one in, as long as it achieves that purpose, I don't really care. So I'm not mandating that particular waveform. It's just got to do the job. I don't know if that would help.
And then just an FYI, Dr. Hassan, Colonel Winterly, Lieutenant Colonel Wendleton, if you guys want to come back on, and just make this more of an open discussion, just as an FYI. And then for the waveform winners and other smaller businesses, feel free to start asking questions if they come up during this session as well. We want to make this as collaborative of a discussion as possible. So are there any thoughts from any of the waveform presenters or anyone else in the audience kind of on this topic as well, just with ownership and any issues from that perspective? All right. I guess another question that comes up with some of this is ownership of intellectual property. And I want to throw it out to the group. What, in terms of having more of an open source software platform and moving through the processes, what concerns do you think come into play with regards to IP partnership and those interactions? Any thoughts there?
I think IP can be easily protected as long as we have standardized hardware that it can run on. So, IP can be, the waveforms can be provided in executable form rather than source code. And as primes, we're really not looking for source code. We want waveforms that run on a set of hardware, and it's really defining the hardware in a standardized form that will allow waveforms to run is an important feature. General Atomics, we don't make the hardware ourselves. We buy integrate products, and we are open to actually buying standard hardware and standard software and integrating it together. That is something that we would be interested in doing, but the interfaces need to be defined between the waveform and the hardware. So.
This is Dr. Hassan from PDM Waveform, PMTR. I would rather ask this question in a different format, and the question looking from the X-Tech aspects, I want to ask the primes, like how a small business could work with a prime maintaining or protecting their IP. Maybe I want to ask first Mr. Alan Treble, and then Mr. Wesley Buss, and maybe then Mr. Akbar. In a short and sweet answer would be appreciated. Thank you.
Oh, thank you, Dr. Hassan. I'm Alan Tribble. I'm the Associate Director for our Advanced RF Solutions within Collins Aerospace. That's a relatively new name for us. We started life as Collins Radio, and most recently we're Rockwell Collins, but as a result of a merger with United Technology, became Collins Aerospace about 3 years ago. So I think it's a great question. How does a larger prime like Collins work with a small business while protecting everybody's IP? And I think that normally when we think of working with a smaller business, we think of a subcontract relationship where, Collins would extend a subcontract to whoever to incorporate their technologies into some program or record delivery that we would make to the government. And in our particular case, we are a PEO C3T contractor. We provide PRC 162 manpack radios to PMTR, for example. And so if there needs to be some agreement where we have the right to include that IP in our product, we need to understand what that is and what the breadth of that IP is. Is this IP right? Maybe it's a licensing agreement restricted just to this radio, to this customer, or is it broader than that? Those are the kind of discussions that we need to have. Alternatively, we could envision working with vendors to develop an ancillary that could use as a modular plug-in to work with our federated or our modular solutions. So I think there's a number of ways that we could go depending on the business model of the prime as well as the business model of the small business.
Thank you. Thank you.
Any other thoughts around IP, Wes?
Yeah, so for us, at Lockheed, we don't, again, much like GA, we don't build radios and waveforms specifically. We actually are an LSI, and that's kind of the way we do business. Is we purchase various items from a lot of people. What we like to own, and this kind of goes back to my earlier comment, what we like to own is the standard. So if we're identifying vendors to put stuff in there, we're not interested necessarily in harvesting intellectual property. We just want to know what that intellectual property is and have it declared so that it's protected for our vendors that are providing stuff to us. But what we're really interested in is making sure that anything that's developed including intellectual property, by vendors out there is compliant with the standard that we provide. And that allows us the assurance that when we integrate the system, that we get the system performance that we're really looking for. So that was kind of the nature of my earlier comment about owning performance versus owning the design and who's responsible for what and how that impacts program outcomes.
Awesome. I wanna take the chance now to open up the entire panel for questions from the audience. Is there anything anyone would like to ask any of the prime vendors, any of the PEO C3T representatives? Just broad questions out there.
Yeah, hi, this is Ashwin Amana at Andro. Question for the panel regarding, I guess, business case of waveforms, monetization of waveforms in the future. Something I just don't understand how, we have these waveforms implemented, and what's the long-term, say, teaming with a radio vendor and either licensing that software to them. I just don't understand where the long-term monetization path is, if it's like per unit sold or if it's a single license fee, or is it more having the expertise necessary that when work comes in, you'll be kind of in the lead position of getting that work. I'm just curious your thoughts on that. Over.
I mean, I'll be glad to share my thoughts. I think that you hit the three options right on the head there. Either there could be a single fee where we would, basically buy the rights to use that IP in our products, or we could do it on a per unit basis, depending on how many units, radios we would see delivering, or we just have an agreement where anytime that we need to change that module, it needs to evolve to emerging requirements, that work gets subcontracted back to you all, since that's you all are the experts in that. So, and I think it really just depends on the specific case, and again, to use the term a little loosely, but the business model behind it is really going to drive us, I think, which of those solutions is the right answer and the best answer for all the participants.
To some extent, there are some successful models out there right now, right, where a vendor sells a radio to the government, for example, and what happens is the sale of that radio has certain waveforms that'll run on it, but there's other waveforms that are either more newly implemented or perhaps cost more money to implement and so on, at which time, a configuration tool based on almost like a node lock license will grant access to that waveform to be loaded onto a specific radio. To the Colonel's earlier point, that the radios in the marketplace now are software-defined radios. I'm starting to believe that hardware eventually will end up standardized. And to answer, the opportunity portion of your question, I think that's where the biggest opportunity is the hardware becomes more and more standardized. The bigger opportunity is who can develop the best application. And when I say application, in this particular context, I do actually mean the waveform that you're talking about. There's also two other things real quick. When you say waveform, I always think of two things. The waveform portion of itself is, think of an application that runs on the hardware. What I think is more challenging is the OE that supports the hardware and interfaces with the hardware, not the application being the waveform itself. So if you're talking about developing OE to run on a specific hardware, I think that's more challenging to address in terms of monetizing than it is the waveform application that runs on top of it itself.
I want to comment on the whole integration of new waveforms and putting it on platforms. We make basically airborne systems, and we've had last few years, 2-3 years, we've been wanting to integrate a lot of new waveforms. I kind of give you some examples, like a MIMO waveform, for example, or a TSM type waveform, things like that. But the problem you have is that there is no qualified airborne hardware available to put those waveforms on. And whenever we try to go buy those waveforms, and we are presented a huge bill to make airborne hardware for that waveform. So not every project is able to afford an NRE to host a new waveform on a new piece of hardware. So I think the biggest contribution that I think in the future, if the Army PMs can do, is to come up with standardized tactical and airborne hardware that can host multiple third-party waveforms. That would be the biggest, I think, contribution that we would recommend to the government side to bring forth, because an individual prime, even though we have larger contracts, a project can't afford a huge tens of millions of NRE for putting together a radio system. So.